This is section 10.6, solving quadratic equations with the quadratic formula. You can use the quadratic formula to solve any quadratic equation in standard form. This is what we've really been building toward these last two chapters, and that is we're always trying to solve for x. We've been factoring, but some things are not easily factorable. The quadratic formula will work to solve any quadratic equation as long as that equation is written in standard form. So first we have to go back and remember what standard form is. Standard form is ax squared plus bx plus c equals 0. This is the quadratic formula, and you have to know this quadratic formula, so you need to memorize it. It's x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2 times a. In this case, a cannot equal 0 because we need to have an x squared term, and b squared minus 4ac is greater than or equal to 0. Just take my word for that at this point. They're not going to explain that to you for a couple more sections, but that is the only way it's going to work. All the examples we will look at will actually follow that pattern, so you'll be fine. An easy way to remember this is to use a song to remember the equation, and that way every time you use it you can just sing the song. So the song that I use is the Notre Dame fight song. It makes it really easy. Okay, so it goes like this: x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2 times a. Da, 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 da. Okay, so we'll practice that in class. You can go over it again, listen to it here. It will help you remember where those variables are, because you're going to have to look at equation and pull those coefficients out and plug them into this equation. So here's example 1. We're going to solve this 3x squared plus 5x minus 8 equals 0. You can see you can fool around with this for a while and try to factor it, but you're not going to be able to. The only way to solve this is to use the quadratic equation. Again, the quadratic equation is x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2 times a. So you look at the coefficients before the x squared, the x, and the constant at the end. So you have your a, your b, and your c. You may want to write those off to the side so you have those defined at the beginning, and then plug them in. So we get x equals the opposite of 5 plus or minus the square root of 25 minus 4 times 3 times negative 8 all over 2 times 3. And you can simplify that so that it's x equals negative 5 plus or minus the square root of 121 all divided by 6, which comes down to x equals the opposite of 5 plus or minus 11 all divided by 6. That means you get two answers here, x equals 1 and x equals the negative 16 divided by 6, or negative 8/3. Okay, when you get two answers with a quadratic equation, what does that mean? That means that parabola is crossing the x-axis twice. It has two x-intercepts, one at 1 and one at negative 8/3. Here's another example. 2x squared minus 7 equals x. This one's a little trickier because it's not in standard form. So the first thing you have to do is put the equation in standard form. So bring everything over to the left and put it in order by exponents. So it's going to be 2x squared minus x minus 7 equals 0. Again, define all your variables. So a equals 2, b equals negative 1, c equals negative 7. Write the quadratic equation down. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2 times a. And then substitute those variables into the equation. So you end up with x equals 1 plus or minus the square root of 1 minus 4 times 2 times negative 7. Divide that all by 2 times 2. So that simplifies to x equals 1 plus or minus the square root of 1 plus 56 divided by 4, or x equals 1 plus or minus the square root of 57 plus 4. When you solve for both answers, you get x equals 2.14 and x equals negative 1.64. So again, we got two results. That means the parabola is crossing the x-axis twice. You have two intercepts, one at 2.14 and one at negative 1.64. If we look at the equation back up at the top, you can see that the coefficient before the x squared term is a positive 2. That means this parabola is upward facing. So you've already got a good start for graphing the parabola if you need to. In example 3, we're going to try to solve a word problem. So here's the problem. For the period 1971 through 2001, the number of films produced in the world can be modeled by this function. Y equals 10x squared minus 94x plus 9400, where x is the number of years since 1971. They want to know in what year were 4,200 films produced. So what they're telling you is what the y value is. The y value is 4,200, and they want you to solve for x, that is the number of years since 1971. So you're going to rewrite the function and substitute 4,200 for y. So it's 4,200 equals 10x squared minus 94x plus 3,900. You have to bring all your values over to one side and write it in standard form. So the equation now becomes 0 equals 10x squared minus 94x minus 300. This is very difficult to factor, okay? You would struggle with this for a while, but you know the quadratic equation will always work to solve for x. So we're going to substitute our values into the quadratic equation. Again, set up what your variables equal. A equals 10, B equals negative 94, C equals negative 300. So when you substitute the values in the quadratic equation, you get x equals the opposite of negative 94 plus or minus the square root of negative 94 times 2 minus 4 times 10 times negative 300. Divide all that by 2 times 10. That can be simplified to x equals 94 plus or minus the square root of 20,836 divided by 20. So when you solve, you get two answers, x equals 12 and x equals negative 13. That's a negative 13. Because this is a word problem, we're only looking for positive values. You can't go backwards in time, so there's no negative value that will work, even though mathematically you're going to get a negative value. So discount the negative value and use the number 12. That means in year 12, 12 years after 1971 or 1983, 4,200 films were produced. So here's the review. So far in this chapter, we've looked at solving quadratic equations in a number of ways. They gave you several choices and several methods, and some of them work better in some situations than others. The first one is when you can factor easily. That means you might be able to see a pattern, a difference of two squares, a perfect square trinomial. Or you could find two numbers that multiply together to equal C and add together to equal B. If you can do that, then I would factor it. We worked on finding square roots. So when you have something simple that can be written in the form as x squared equals d, you could just take a square root and solve it. We completed the square. You can use that with any quadratic equation, but I can tell you it's much, much simpler if a equals 1 and b is an even number. If it's not, I would not fool around with completing the square. It's probably going to drive you crazy. And lastly, the quadratic formula. The quadratic formula you can use with any quadratic equation. It will always work. You will always get an answer. So when in doubt, use the quadratic formula. That's why it's so important for you to memorize that equation. Okay, so here are three quadratic equations. Take a look at the three and decide what method you would choose to solve them. Okay, so take a second, pause this if you need to, and think about each of these. In the first one, it's really not easily factorable. I think it's sort of difficult, and completing the square is going to result in a whole bunch of fractions and a mess because of that 3. So I would use the quadratic equation for the first one to solve it. The second one can easily be switched into x squared equals d form, so I would solve it by using square roots. Just set it up so that 9x squared equals 3, divide both sides by 9, and then you can take the square root. In the last one, I would probably use factoring. You see you have a common factor there of an x. You can take that out so that you have x times the quantity x plus 8, and then just set both expressions with the variables equal to 0 and solve for x. If you don't want to do that, you could definitely use the quadratic equation, or you could use completing the square, because the coefficient before the x squared term is 1, and the coefficient before the x is an even number, so that would make it really easy. But I think completing the square is much more difficult than using one of our simpler factoring methods that we used earlier in the chapter. So I would probably just take out the greatest common factor and solve it that way. It's going to take a lot less time, especially when you see something like this on the test. On the test, you're going to see a whole bunch of different quadratic equations with no requirement of how to factor them. You just have to factor them. So you have to be able to look at them and recognize what method is going to be the most efficient and the easiest way for you to use.